Alright, I thought I would show a little bit of how the LogiX for this thing works, just in case you want to customize it or use it as a template to build your own thing. So if we look at this, the LogiX is broken down into separate modules. So the stat reader contains the LogiX. I forgot to get out a LogiX tooltip, give me a second. The stat reader contains the LogiX that communicates with the Python server and gets your computer performance statistics. That's perfmon stat reader LogiX. And this is a little messy because I had some of it in blueprints. And when I packed it away, obviously the blueprints disappeared. Now there's a fair amount of stuff here that isn't really essential. So this LogiX here is only setting what user the impulse runs as based on your configuration. So it either runs as host user or it runs as the username that you've entered. Oops, sorry. And this LogiX, all this stuff here and all this mess back here, this is only to reset the gauges to 0 in case of a loss of communication. So you could delete everything here, not the sequence, all these write nodes in the sequence back there, and it would run just fine. But when you lose communication, your gauges would be stuck at whatever the last known value was. They wouldn't reset to 0. Which, by the way, if you're running them as a particular user and you leave the world, the impulses will stop, so that's equivalent to losing communication. All this is doing is this integer here is a variable, and every time the GET request succeeds, it resets that integer to 0. And once per second, it increments that integer by 1. So it's constantly counting up by 1 every second, and every time you successfully get data from the Python server, it resets to 0. And then if it exceeds either 10 or 3 times the interval you've set, so at smaller intervals it will be 10 seconds timeout, and at larger intervals it will be 3 times your interval, then it goes over here, runs to this sequence, and just writes 0 into everything. So the thing that talks to the server is just this tiny little bit right here. It just has a timer, runs a get string, and writes it into a string variable. And you can see it comes in as a comma separated value. So there's 8 values here separated by commas. And then this messy bit here is was a blueprint that I put together that just splits the string into parts. So all this stuff is just to do a string.split on comma, and it comes over here, and for each of the 8 components in that string, it sends out an impulse with the index 0 through 7 and the string value that it parsed out. And that happens right here. So you get 8 impulses, each one with an index going up to indicate which part of the string it is and the actual string value. And then all that does is parses it to a number, and then using a multiplexer based on its index, it writes it into one of 8 different value fields. Now the value fields right here are interesting because if you look in Performance Monitor, Stat Reader, Data, let me just get rid of this first, clean things up a little here. So all of your data that's coming back from the Python server script is just writing into 8 value fields, which I've labeled here. So CPU load is right there. That value is always the latest version that it read from the server. Same with all the others, like number of bytes sent. And that's really handy because if you want to hook this up to something, you don't have to open up any of the LogiX that reads from the server. You just come in here, grab the value field you want, pull it out. And, there's your CPU load, and you can hook that up to do whatever you want with it. Or We can grab the core load too. There's our core load value. So if you want to do a custom display of any type, you just come in here, stat reader data, and pull the data you want out of these 8 values. You can delete gauges entirely. It will have no effect on anything else. It won't break it. Now the gauges, they've got kind of 2 parts nested with each with their own LogiX. Sorry, losing track of what I'm doing. Okay, gauges, you have a gauge that is for one thing in specific, like the core load, the CPU load, the memory load, or memory percentage used. And then inside that, you have another thing called gauge. This one is just the raw display of 0 to 100%. It doesn't contain that text on the bottom or that text in the middle there. And that has its own set of LogiX, which just handles moving the indicator arrow back and forth based on this value field here. So you just write a value from 0 to 1 into this value field here, and the arrow moves automatically, and LogiX is packed up separately. And then the named thing, like core gauge or memory gauge, that, what do I do with my LogiX tooltip? Anyway, that named gauge contains the LogiX that interprets between this data coming in from the stat reader and the gauge there. So core gauge is a simple example because the data is coming in percent and it's displaying percent. So you can see here it's getting a value, and that's coming in from that value field in the stat reader, applying a smooth lerp just to make the arrow move smoothly instead of jumping every time you get data. Divide by 100 and write the value in. So that's your 0 to 1. And then down here, this is just your string format that is displaying this bit right here, the 37%. Very simple, not much to it. Now some of the other gauges are a little more complicated because they have to interpret. Like the memory gauge, if you look in stat reader data, you have memory total, memory available. So that takes a little bit of math to convert between available memory, total memory, and percentage, and then display the actual memory used at the bottom. I have no idea why that appeared a mile away. But yeah, you can see the memory is a little more complicated. Oh, this part was in a blueprint too. This is just a little function. You give it a value, a floating point value, and it converts it from raw bytes into kilobytes, megabytes, and gigabytes for display. So now this is sending in whatever the value is up there and converting it to gigabytes or gibibytes to be technically correct. That's with 1024 per 1,000 instead of 1,000 per 1,000. All right, let's get rid of that. Well, anyway, that's probably enough that if you feel like going in and customizing anything here, you can see how you can get at that and customize it. I didn't want to make this too awfully long a video here, so just the basics.